Okay, so the first part of this video is going to be about changing the x values. So we're going to make changes to the x's. The y's are going to stay the same, and we're going to look at what kind of transformations are made. So you have a new function, a new monster we're going to be looking at. So we're going to start with number 2, because number 1 changes y values. So we're going to start with number 2, and we have our new x values here. And our first step is to take the opposite. We're taking the opposite of the x. Here's our function, taking the opposite of the x. So the opposite of 6 be negative 6, negative 4, negative 4, negative 2, the opposite of 0 is 0, and the opposite of negative 4 is 4. Then if we go back and look at our table on the front, when our x value is negative 6, so now we're taking the function of negative 6. When the x value is negative 6, our y value is 0. When x is negative 4, our y value is negative 2. When x is negative 2, our y value is 2. When x is 0, our y is 0. And when 4 is 0, our y is 0. So for this first half of the video, these are going to be the same, because our y values were not changing. We're given new x values to transform to get the same y. So then when we graph it, you're really going to be graphing 6, 0, 4, negative 2, 2, 2, 0, 0, and negative 4, 0. So get 6, 0. Oops, not far enough. There we go. 6, 0, 4, negative 2, 2, 2, 0, 0, and negative 4, 0. So then we just need to say what happened to our function. And here is our original. So we have a flip, a horizontal flip. So next to number 2, or under number 2, we need to write that this was a horizontal flip. The next one we have is number 5. So number 5 says y equals g of x plus 3. So if it's happening inside the parentheses, we're changing our x. So we're given some new x values to change the x. So negative 9 plus 3 is negative 6. Negative 7 plus 3 plus 3 plus 3 and plus 3. Now when I take these values and I look back at my original table, remember my y values are going to stay the same. So I compare those tables, and these are the y values associated with each of those x values. So now I'm going to graph using these x's and these y's. So I'll pull that out, and I have negative 9, 0. So here's what you have, and I shifted it 3 units to the left. You can kind of compare the two. This started at negative 6, and now it went 3 units to the left. So if I have x plus 3 on the inside of the parentheses, if I'm changing the x by 3, it's really going to the left. Let's do the next one. Now I'm doing x minus 3. So again, inside the parentheses, changing my x. I have new x values. Negative 3 minus 3. Minus 3. Minus 3. I am not focused right now. Minus 3. Minus 3. 1 minus 3. Negative 2. Sorry about that. Minus 3 is 0, and minus 3 is 4. And then this is negative 6, negative 4. I was looking at the wrong table. We're all good. Okay. Okay, here we go. We replace, we get the same y, because we had new x's, we get the same y. And now we're going to graph these x's with these y's. So now when we do that, now I scooted 3 units to the right. So x minus a number is going to go to the right. So subtracting the x's inside the parentheses goes to the right. Number 9 is your next one to look at. So number 9, we have a fraction coefficient of x inside the parentheses. We're given new x values. 1/4 of negative 24 is negative 6. 1/4 of negative 16 is negative 4. Negative 2, 0, 4. Remember, our y values stay the same. That's the whole point. My x's didn't change, my y's changed. And so when I have a coefficient, what ends up happening, if it's a fraction coefficient, negative 16, 2, 3, 4. Oh, negative 16, negative 2. Here we go. So it stretches it out. You won't be able to put this dot on your graph, which is fine, or you can scoot it out like that. But so a fraction coefficient stretches it horizontally. Okay? Moving on to number 10. Now I have a whole number coefficient. New x values, multiplying each one by 4. Negative 6, negative 4, negative 2, 0, 4. Looking back at the original table, when the x is negative 6, my function equals 0. When the input's negative 4, my function's negative 2. When the input's negative 2, my function's 2. When the input's 0, my function's 0. My input's 4, my function's 0. So we graph the x's and these y's. And we get negative 1.5 is a 0. And it looks like this. So now we have compressed it horizontally. So going back over those, little recap. Number 2, we flipped it horizontally. Number 5, we shifted to the left. Number 6, we shifted to the right. Number 9, we stretched horizontally. Number 10, we compressed horizontally. Okay, so now we're going to do the y's. So this is how the changes to the y affect the graph. So now it's a little bit different. We have the same x's over and over again. So when we have those x's, remember these are our y values. I'm sorry, these are our outputs. And I'm going to change the output. We're doing something different to the output. Something is changing to the output. It's not inside the parentheses, it's outside the parentheses. So we're changing the output. So I change the output. I'm doing the opposite of each output. And then these are your new y values. Oops. So now when I graph that, I use my x's and my new y values. And what happened here is it flipped vertically. So I have an opposite of the function, I flip it vertically. Not an opposite of the x, an opposite of the function, I flip it vertically. Moving on to number 3. Our outputs always match. These were our inputs originally. We're using the same output. We're changing the output. We're adding something on the outside of the parentheses. So we're just going to add 3 to each of these numbers. And then these are going to match the y's. So now you're going to graph your x's and your y's. So I'm going to pull this out and it'll be at negative 6, 3, positive 3. So I just shifted the whole thing up. So adding outside of the function shifts the function up. Moving to subtracting the y's. We have our x values, we have our outputs. So we're going to be subtracting 3 from each of these outputs. Negative 3, oops, negative 3, negative 5, negative 1, negative 3, negative 3. And your y's are going to match those. So you're graphing your x's and your y's. So negative 6, negative 3. So now I've shifted the function down. So changing the y's by subtracting, you shift the function down. Number 7, multiplying by 4. So we're multiplying our function by 4, multiplying our output by 4. These will match the y's. So I multiplied my output by 4, graphing the same x value with the new y value. And I have expanded vertically. So multiplying by a coefficient larger than 1 expands it vertically. Remember, everything's always the opposite for the x's and the y's. And the last one we need to do is a coefficient of less than 1. So we're going to be multiplying our y values. So then those y values are going to match. And then when we graph it, it's going to be really tiny. You have to do your best on your graphs. So I'll pull this out. And our x values stayed, but our y values got super tiny. So we have compressed it vertically. So we run back through these last ones. Number 1, when you take the opposite of the function, it flips vertically. Number 3, adding to the function shifts up. Number 4, subtracting from the output shifts down. Multiplying the output by a coefficient greater than 1 would expand it vertically or stretch it vertically. And number 8, a coefficient of less than 1 would compress it vertically.